Welcome to this video. Today we'll be looking into algebraic methods. In particular, in this chapter we'll be going through simplifying algebraic fractions, then dividing polynomials, then we'll look at factor theorem, and then some mathematical proofs. They are very simple mathematical proofs, so nothing to worry about. To start with, let's have a go at the prior knowledge test questions. I suggest you pause the video here, have a go at these questions, and then play the video and compare your answer with me. Alright, I hope you've had a go at these questions. They're fairly simple. This very first question is just applying index rules. So 3 and 5 are coefficients, they have to be multiplied with each other, but the powers will add up. So that's what you will get. Next, you check there is no plus or minus signs between these terms on the top and the bottom, so everything on the top can simplify with everything on the bottom, so you don't have to factorize anything in particular. You're just looking for highest common factor that you can pull out of both the top and the bottom. The highest common factor of both top and bottom with regard to y is y squared. So we can cancel that out, and dividing y cubed by y squared or subtracting a 2 will leave a 1 here. Then the highest common factor of x cubed and x squared is simply x squared. So we can cancel that away and subtract 2 from 3. There will be x to the power of 1 on the top and y to the power of 1 in the denominator. Then 5 and 15 will leave us a third, so we end up with this fraction here. Factorizing this expression will leave us with these two brackets. Then one more time, for answering part B, 2b, my methodology is to take this 3 and multiply it by 20, so we can rewrite this as x squared minus 17x plus 60, and not forgetting that we multiplied and removed the 3, so my last step will have to involve a division by 3, because I multiplied this 20 by 3. So factors of 60 that add up to negative 17. 60 divides by 6 and 10, 5 and 12, I think we've had jackpot, minus 5 and minus 12. So we write minus 5 here in the first bracket, and then minus 12 in the second bracket. And we think now we need to divide by 3. Well, the 12 does divide by 3, but the 5 doesn't. So what I'll do is I'll divide 12 by 3, and I'll write the answer as x minus 4. This bracket, these two simplify, but because 5 doesn't divide by 3, I'm gonna multiply that factor by 3 so that it will have linear terms, so it will get a 3x minus 5. It will become 3x minus 5 rather than 5 over 3. Right, so that's the simple factorized version of this question here. So first step, we multiply the 3 by 20, and then we divide by 3, so everything works out. Now next question involves you to actually perform long division. Believe it or not, this method without a calculator, where you learned in primary school, will be used in these next few lectures. So that would involve you writing this as a busted method. In England, we write the larger number that you're dividing by on the right, and 9 here. You ask yourself, 1 doesn't have a 9 in it, so I leave it. I'll go to 1 and 9. 19 divided by 9 is 2. I write 18 here and subtract, and so on and so forth. So this 1 is the remainder, and then I bring the 17 down. 17 divided by 9 is 1. So I write negative 9 and I subtract, and I'm left with 8. I bring the 5 down here, x to 8, and so on and so forth. So you should try this method and learn it, and you will get these answers. And the last one, part B, will give you a remainder of 3. Now, looking at question 4, you have to find the equation of these lines, which I'm not going to explain again. So you can watch the when I explain chapter 5 what we do here. These are the answers you should get. And completing the square here, once again, you should know. If you haven't learned it, go and watch videos on chapter 2, and you will have learned it by then. Alright, so I'll see you in the next video for the first lecture.